Good afternoon. Thank you very much for kind introduction. And I'm very honored to be invited to the third Asian Innovation Forum. I'm very glad to be here with distinguished speakers from Asian countries. Theme of this session is the new paradigms of R&D system. And if I may say my observation first, as long as the Japanese science, technology, and innovation policy is concerned, a new paradigm is apparently emerging, and it is vision-driven. So, today, first, I will elucidate the paradigm shift by reviewing the transition of Japanese SDI policy. Then I will briefly describe specific examples of KISTEP's contribution to national SDI policy development and review. And finally, let me introduce some insights on future design of SDI policy for your consideration. So, in Japan, government has developed 5-year science and technology-based plan since 1996 to ensure comprehensive and strategic implementation of various policy measures to promote science and technology. The first and the second plan focused mainly on the expansion of scientific research capacity and seeds-driven technology transfer. They addressed science and technology human resource issues, especially young scientists, and the expansion of competitive funding for research and development of research facilities and infrastructure. In the third plan, for the first time, science and technology policy was related to national challenge and objectives, such as sustainable development, safe and secure nation, and vibrant lives. The word innovation appeared for the first time in basic plan. However, it was mentioned in the context of product and process innovation to maintain industrial competitiveness. Here, I should touch upon the Innovation 25. 6 months after the third basic plan was decided, the first Abe administration was formed, and there came an instruction from Prime Minister Abe to develop a long-term strategic guideline for innovation. And Professor Kiyoshi Kurokawa was invited to Cabinet Office to lead this effort. And in this endeavor, innovation was defined not as a just introduction of new products and services, but a societal and economic change brought about by such new products and services. It was different from the science and technology basic plan in that it put forward societal vision of 2025 to be realized by innovation. It also addressed societal and institutional aspects influencing innovative capacity of a nation, such as diversity, globalization, deregulation, new societal institution, and mindset. In a sense, Innovation 25 was an innovation in science and technology policy. The first plan was decided upon in August 2011. It announced that the science and technology policy and innovation policy was integrated in the plan. However, such innovations were prioritized to cope with clear and present challenge at the time of Japan, namely aging demography, scarce clean energy sources, and restoration from the East Japan earthquake and tsunami. The latest fifth plan, like its predecessors, addresses expansion of scientific research base and identify scientific research areas to cope with national societal challenges. However, in addition to that, it has introduced a new concept to create a new society, Society 5.0, through innovation. Society 5.0 is defined as the result of successive development of society, meaning Society 1.0 was hunting society, 2.0 agrarian, 3.0 industrial, 4.0 information. Society 5.0 is characterized as the inclusive, vibrant society where individuals' various needs are differentiated and met as necessary by merging real world and cyberspace by ICT. To facilitate innovation to create such a society, the plan urges to establish global open innovation system and virtuous sustainable cycle of human resources, financial resources, and knowledge. This is a large transition from previous 5-year plans, and it appears to me that the plan capitalizes on transformative power of new technology and innovation to rapidly change society and economy. As you can see, the Japanese SDI policy has been changed from what I call supply side to vision sharing. In earlier days, most attention was paid to the expansion of supply side, namely scientific research capacity. Then came what I call demand side SDI policy, where the SDI system is expected to address clear and present challenge of a nation. But now, it put forward the future societal vision of Society 5.0 and calls upon every component of SDI system to work on to realize it. It is crucial for multi-stakeholders related to the SDI system to share the future societal vision and play each one's role. So let me now turn to some specific examples of KISTEP's original analytic activities that support development of SDI policy and program. The first one is a science map. It identifies the hot research areas receiving high international attention by co-citation analysis of top 1% papers of the world. It also identifies papers leading each hot research areas and the relationship between hot research areas. The map has been revised every 2 years, and the latest one, 2014, identifies more than 800 hot research areas. The map provides information regarding the emergence of new concepts or viewpoints in science and specific communities of researchers working on them. The map has been utilized in Science Ministry and National Research Institutes to identify research themes in some strategic R&D programs. The second one is the expert survey on Japanese SDI system. The objectives of this survey is to continually monitor the progress of science and technology basic plan, especially the policy measures to expand scientific research capacity and to facilitate innovation. The latest round of survey is directed to the fifth basic plan, and more than 3,000 respondents are enlisted from top managers to young researchers in universities and national research institutes, and from those working in business on academia-industry collaboration. So here are some examples of the result of our survey for the last basic plan over the 5 years. The flexibility in the most popular research grant, granting aid for scientific research, got the highest in upward change in satisfactory score, and its satisfactory level is excellent. However, baseline funding for universities and the National Research Institute and the number of qualified PhD candidates got large satisfactory score down, and their satisfactory level is poor. So these changes and the satisfactory levels being duly considered in the development of the latest risk graph. The third one is an example of exploratory analysis, which every NICEP researchers are encouraged to run. In this study, one of the NICEP researchers undertook a multi-dimensional measurement of innovation outputs of firms. He conducted empirical analysis of firms' innovation activities using firm-level microdata from National Innovation Survey and patent and other literature-based innovation output indicators. The study indicates that literature-based indicators are important to measure the multidimensional characteristics of innovation outputs at the firm level. The last one is the foresight. The NICEP foresight has been an important input to science and technology-based grants. Foresight has been conducted every 5 years. In its early days, foresight was supply-side activities. A few thousand scientists and engineers' views were collected to generate a consensus view as to what technology would be realized when. Delphi technique was employed to converge their view. Then, thereafter, demand-side views have been incorporated, and experts in social sciences and humanities have been involved. In the last round of foresight, NICEP adopted the new three-step approach. The first step is to describe future societal vision. The second step is to review future perspectives on science and technology. Here, still a few thousand experts are employed, enlisted. And third step is to develop a scenario to realize the societal vision. And in this first trial, we have got some lessons. The societal vision was not comprehensive enough to elucidate the future of our whole society, but it was just a pre-structured list of societal issues and challenges to be addressed by technology and innovation. So, based on the lesson, NICEP is now conducting a few rounds of local workshops to refine methodology and improve our capacity, ability to conduct the process more efficiently and effectively. And so that we can later be prepared for the next round of national level foresight. So, let me tell you some thoughts on future design of SDI policy. In view of enormous transformative power of new technology and innovation, it will no longer be the ultimate objective of SDI policy to expand scientific research base. Rather, it seems to me the goal of SDI policy is to guide a societal transformation by new technology and innovation, so that the society will be transformed as people benefit. SDI policymakers will be responsible not only to scientists and engineers, but also to people of our country and the world, today and tomorrow. How we, SDI policy research think tanks, can best support policy makers. Above all, we must better understand the interaction between technology and innovation on the one hand, and society and the economy on the other. society and economy may need a technological fix to address any issue or challenge. Steam power and electrical power were examples of this. In older days, time constant of societal economical change was much longer than that of technological change. However, recently, ICT has changed the landscape. Now societal economical changes take place rapidly and widely. Furthermore, societal economical changes sometimes went beyond the intention of the original inventor and the original intention of inventor or developer. Take internet, for example. The intention of initial developer was to devise a network where computers communicate with each other. However, as you can see, internet combined with mobile devices, mobile communication technology, and SNS services has changed people's lives. Moreover, MOOCs and other online media provide more people with educational opportunities. And SNS is said to have played a role in enhancing democracy in Arabic countries. At the same time, some organizations with non-democratic hostile causes are using SNS and its website to promote their cause. Cyber attack is a new threat to society. So as you can see from this example, societal economical transformation was beyond the intention of initial developers, and it's enormous, and the change was enormous. Furthermore, bad effects may ensure as well as good ones. So, having said that, this is the future prospect for foresight. First, we need to capture early indication of transformative technology and innovation. KISTEP has developed AI-based search function for this purpose. At the same time, I want to underline the importance of human expertise in this exercise. Then we assess possible societal transformation by such technology. We are expected to provide evidence-based information of future development technology. At the same time, it is important to take into consideration every possibility of two-way interaction between technology, innovation, and society. For the latter part, sometimes we may not have enough evidence and have to rely on our insight. Then we can provide a platform for sharing the future society vision. Future society will be influenced by technological development and innovation, but at the same time, we have to seriously think about how we want to or should change society. The latter part will not be answered by just collecting experts' views, but only by painstaking deliberation involving various stakeholders. This process is important to enable policymakers to make informed decisions. Only based on these building blocks, we could prepare policy measures and roadmap to realize a societal transformation. Because of ever-increasing interconnectedness in this globe, future vision exercise, although it's national or local, must be undertaken in global and regional context in mind. And that's why I want to underline the importance of global and regional collaboration in foresight. And KISTEP is going to host the international conference on foresight in November this year. And you can, we are expecting your active participation. You can find a flyer of the conference in the distribution desk over there. So, let me conclude. STI policy was traditionally about expansion of scientific research base, but now it is becoming vision-driven and vision-sharing exercise. Still, expansion of scientific research capacity is an important part of STI policy. And vibrant reservoir of new scientific knowledge is prerequisite for innovation. Especially, it will always be most important thing in our system to enable young researchers to try every idea, to become independent thinkers and doers, to innovate and change society as we wish. Although I did not mention specifically, there is an indication that open science may change paradigm of SDI policy, especially with respect to scientific research capacity and public participation. For SDI policymakers to be responsible to the people on the earth, both today and tomorrow, the policy-making process has to be evidence-based and informed. And in this respect, there are a lot for SDI Policy Research Institute has to do. In vision-making exercise, multi-stakeholder participation is essential. And also regional global collaboration in future vision development will be getting more important to enhance more collaboration on sustainability. Societal transformation must be going on so that every people on the earth got its benefit. That's why foresight is critically important and young people have to be involved in it. At the end of the day, future is theirs. So, thank you very much for your attention.
Thank you.